Yeah. So it's the previous classes, just introductions completed. So today we'll start actual subjects. Yes. So 30th April. Yes, day one. See, say about myself, about course content on this, all these introductions discussed. Okay. Just 5 minutes, only 5 minutes. About myself, this is Nageswar, 20 plus years of experience as a Java developer. Okay, leave it. Next course, 75 days time. Yes, 8:30 to 10 o'clock. So next week, 8 o'clock. Next week, I'll take it 8 o'clock. Yes, on the request of working professionals, I'm making 8 o'clock next week. Yes, session duration 90 minutes. 90 minutes, Monday to Saturday classes. Only Sunday holiday. Next, daily recordings, class document, Java code, and all the sharing with you. Yes, anyone wanted to continue for next second time also you can continue issue. Next batch also you can continue. Correct? Yes, 3 demo classes are free of cost. Yes, no worry. I'm not a commercial. Take your own time. Okay. Yes. So fees this much. So this is about your course information. Core Java. After finishing Core Java, anyone wanted to continue for Java full stack, you can continue. Even Java full stack also myself. I'll be taking Advanced Java and frameworks and all that. So here Core Java finishing at any cost in 75 days. About course, right? Next about course content. So initially all software basics and then Java fundamentals like data types, operators, and all this here. So first 1 month focus on coding skills, logic building, and thinking skills. So once you good at this, I'll make you expert in coding. So once you expert in coding, then easy to understand Java. So first of all, I'll make you expert in coding. So once you good at coding, then easy to understand Java. So Java starts. Java object-oriented programming features. After that, other topics in Java like strings, exception collections. Here, this is a main focus on collections. 10 sessions, I'll explain collections. So 50 plus scenarios I have prepared in collections. That real-time scenarios. Next, input output streams, file handling. Next, serialization, deserialization, networking, multi-threading. Finally, Java 8 features 11 and 17. So these things going to discuss. Okay. Yes, 300 plus programs. That scenario is prepared. Same thing I'll explain. That's it. So this is a day one introduction. So day one. Next day two. See about day two. So yesterday session day two. Yesterday Java already discussed what is Java, Java history and all that, right? Of course, this topic will be repeating once again. Once Java started, I'll repeat this topic. So what is Java exactly? About Java history. Okay. Yes, Java history. Yes, all the different editions of Java. Yes, this topic will be repeated once again. Don't worry, guys. Any new today, don't worry. This will be repeating. About Java, this topic will be repeating once again. So once you started Java. Okay, so yes, first time starting software basics. Okay, only 2 classes software basics, then I'll go to Java. Okay, so today, tomorrow, yes, all the software basics. Okay, yes, to understand Java, software basics required. So first of all, I'll take some software basics initially. Before going to Java, there are software basics. So today, tomorrow, all the software basics. Today, tomorrow, all the software basics. After finishing basics, so next session is Java installation, JDK installation, Eclipse setup, and all that. Okay, fine. So day two session, don't worry. Yes, day two session, yes, that will be covered again. Don't worry. Day two session. So day one, just only course introduction. Day two, Java overview. That will be repeated. Day two session will be repeated. No worry about it. Yes, now let us start today's session. Yes, starting from the basics. Starting from starting from basics. Starting from basics. So you can non-IT background students also can understand. So here I'm starting from basics, then finally take to high end. I will take to high end. Yes, starting from the basics. Okay, from very scratch. Without IT background also, you can understand these basics here. Okay, once basics can be completed, then Java starting, then easy to understand. So directly starting Java, some terminology may not be understanding here. Okay, so if I'm starting directly Java, some terminology, some software terminology may not be understanding. So for that reason, first of all, I'll explain about all the software basics. So once is clear, then easy to understand Java. Okay, so let us start with software basics. Okay, yes. So first of all, you need some software terminology knowledge, software basics knowledge. If you have that knowledge, then easy to understand Java. So for that reason, I'm explaining basics first of all. So these 2 days only basics. Once you completed, next I'll start Java. Software basics. Yes, I'm starting from very basic, very scratch. See computerware. Computerware. So computerware basically two categories. There is a hardware. Yes, computerware basically two categories. Hardware and then software. Hardware and software. Hardware and software. Hardware and software. See computer. Yes, computerware basically two things here. There is a hardware and software. Hardware voice is too low. Yes, can you check your system volume? Sarika, can you check your system volume? Yes. So generally here I'm a loudspeaker. I can speak loudly. Yes, no problem. Okay, no issue. I'll speak loudly. Yeah, computerware. See, computerware basically two categories: hardware and software. Yes, hardware and software. Yes. Everyone, am I audible? My voice, am I audible? Is it
Yes,
clear?
sir. Yes, sir.
Right? Samina, Sam, right? Yeah. It's clear, right? My voice is clear. Everyone is good, right? Okay, fine. Yes. So computerware, hardware and software. See hardware. These are physical components of a computer. Hardware is a physical components like keyboards, mouse, monitor, hard disk, and all these hardware components. Yes. Otherwise, sorry, just can you resign again? Can you rejoin the session? Yes. Sarika just rejoin. Rejoining the session. Maybe some issue in your joining something. At the time of joining, maybe audio. Yes, that audio not selected. Just rejoin. Rejoining the session. Yes. Computerware. So here there's a hardware and software. Yeah, hardware. These are physical components of a computer. We can touch all that, like something like keyboards, mouse, monitor, hard disk, all the hardware components we can touch, but not necessary for us. So we are the software engineers. So let us start with software. Hardware is not necessary. So just we are the software engineers. So let us start from software here. Software. Software. See, in software, everything is a program. Everything is a program. Software, everything is a program. In software, everything is a program. Yes, it's a collection of programs. It's a collection. Yes, it's a collection of programs. Collection of programs. It's a collection of programs, right? Yes, like voice programs, C++, Java, and all the programs. That is software. In software, all are programs. Everything is a program, right? See, software basically two categories. Here, software basically two categories. Two categories. Software basically two categories. Two categories. First one, system software. System software. Second one, application software. System software. Next, application software. So software basically two categories. First one, system software. Next one, application software. So what is system software? Yes, what is system software? So system software, yes, it interacts with the hardware components. Yes, it interacts with the hardware components. The system software. So what is system software? System software, it interacts with the hardware components, interacting with the hardware components. Okay, here system software interacting with the hardware components. Okay, yes, for this example, voice, yes, operating system, yes, operating system. Okay, operating system. Okay, system software, it interacts with the hardware components. System software interacts with the hardware components. Example, voice. See, voice can interact with the hardware, interacting with the hardware, right? Yes, today we'll discuss what is voice exactly. I'll explain. Yes, application software. System software, it interacts with the hardware components. Best example, voice, right? Next, application software. What is application software? See, application software. So this is for the purpose of application development. For the purpose of application development. For the purpose of application development. Okay. Yes, application software. Yeah, this is for the purpose of application development. Applications, apps. See, in our daily life, we are using many applications. See, in your mobile, there are many applications, right? In your mobile, many applications. Yes, which is mostly used application in mobile? Anyone can answer this? Which is mostly used application in your mobile? Which is mostly used application in your mobile? No one answer.
WhatsApp,
What?
Facebook, Twitter.
WhatsApp, WhatsApp. So generally WhatsApp, right? So WhatsApp. So WhatsApp. Yes, it has become basic needs in our life. Okay, in our daily life, we are using WhatsApp, right? So many to many communication to friends and relatives and our team members and all that, right? So WhatsApp. Okay, right? Yes. So WhatsApp. Next, maybe banking apps, banking applications. There are applications. WhatsApp. Yes, in your mobile, some banking applications. Okay. Yes, next, maybe online shopping. Yes, online trading apps. Yes, online trading. Yes, in your mobile, maybe some online trading applications, online trading apps. Okay. Yes, suppose here Google Pay, GPay, right? Yes, Phone Pay, and all the applications here, all the applications, right? Yes, Zoom. Now currently we are using Zoom, right? Zoom app. Okay, all the applications, right? Okay. To develop this kind of applications, we need some softwares. Okay. Yes, WhatsApp. Yes, next, banking applications, online trading applications, Google Pay, Phone Pay, Zoom application. Okay, right? So different yes, applications, right? Suppose schools and colleges, companies like this, different manage hotels and all this management, right? To manage all of these things, we need to develop some applications. Some applications required. Okay, automation of all the activities, applications required. To develop such kind of applications, we need some software. That software is application software. So application software for the purpose of application development. So this kind of applications, developing this kind of applications. To develop this kind of applications, we need some software. That software is application software. Yes, application software. Best example, Java. Java is a mostly used application software. Yes, in software, in all we have more than 100 technologies. Out of the Java is a mostly used application software. Compared to anything, Java is a mostly used. Java, next is C and C++, also application software. Next, .NET is also application software. Okay, .NET is also application software. Python is also application software. Okay, databases, also application software. Like this, there are many things. There are many things. Like there are many languages, sometimes tools using, okay, sometimes packages. There are many things we are using there. So all their application softwares, languages, tools, packages. So there are many things we are using, right? All their application softwares. Languages like Java, C, C++, Python, HTML, like this. There are many languages. Those are application softwares. Tools like testing tools, big data processing tools. Okay. Yes, big data processing like Hadoop related tools. Next, infrastructure management like AWS DevOps tools. Okay, next testing tools. Next, reporting tools. There are many tools we are using nowadays. Ticketing tools like that here. Packages like ERP packages, Oracle ERP, SAP ERP, and then Tally accounting packages. So all these are application softwares. All these are application softwares. See exactly which is application software. See, we are using many technologies, more than 100 technologies. We are using hundreds of technologies are there in the market. Okay, so which is exactly application software? Which is exactly application software? See, only ways can interact with the hardware components. Only ways can interact with the hardware components. So OS is a system software. So OS is system software. Except OS, remaining all are application softwares. So except OS, simple here. Simple. So except operating systems. Except operating systems. Here remaining all are, yes, all are except OS, all are application softwares. All are application softwares. All are application softwares. So whatever the, yes, all are application software. So whatever the technology we are using here nowadays, yes, all are application software except OS. Yes, except OS. See, operating systems. Example, Windows is a OS, right? Yes, Windows. Windows is system software interacting with hardware. Windows, Linux. So these are the operating systems. Next, Unix, Windows, Linux, Unix, Mac OS, Mac OS. Next, Android. Yes, in your mobile using Android, right? Android, Android. Next, iOS. So these are the operating systems. These are the operating systems, right? Except this, remaining all are application softwares. Remaining all are application software. Except which remaining all are application softwares. Okay, you working any domain, any field. So any technology, all are application softwares. Except which. Except which remaining all are. Yes, maybe you working in testing. Maybe AWS DevOps. Yes, maybe Hadoop, maybe Big Data, maybe Java, maybe Python. Okay, maybe some tools. Yes, all are application softwares. Yes, it's very clear. Except which remaining are all application softwares. Okay, fine. So let me review. So today started from the basics. Late Chinese. So today late Chinese. So try to listen this. So today started actual subjects. Last two classes taken only introductions. Today actual subject started. Today actual class. Yes, software basics. So starting from the basics, even non-native background students also can understand. Okay, fine. So computer well. Yes, there are two things in this hardware and software. Hardware, these are physical components. Physical components we can touch. Like keyboard, mouse, monitor, hard disk, all the hardware components we can touch. Okay. So that is hardware, but not necessary for us. Yes, let us go to software. We are the software engineers. So starting software. Yes, in software, everything is a program. Everything is a program. It's a collection of programs. It's a collection of programs like OS programs and next to C program, C++, and like that, Java programs, Python, and all that, all are programs. It's a software. So software, everything is program. Software basically two categories. Two categories. First one, system software. Next one, application software. System software and application software. So system software, it interacts with hardware components. System software interacting with hardware components. Example OS. Example. So OS is system software. OS is a system software. Yes, interacts with hardware. Only OS can interact with the hardware. Others cannot. Only OS can interact with the hardware. Others cannot. Next, application software for the purpose of application development. Application development. See this kind of applications like WhatsApp, Facebook, okay, banking applications, online trading, all the online applications. Okay, to develop that, we need some softwares. That is application software. Application software example these things. Java is the most used application software, right? Yes, maybe languages, maybe tools and packages, all are application softwares. See, except operating systems, remaining all are application softwares. Rest of the things here, all of the things are application software. Yes. So operating systems, they are examples of OS, right? Windows, Linux, Unix, Mac OS, Android, iOS, like that different kind of application softwares. Okay, different kind of application softwares. Okay, fine. Yes, now let us say about OS. What is OS? Topic is about OS. See here, so whatever things I'm explaining here, it's there in documents. So you guys not necessary to write any running notes. Running notes is not necessary, just you follow document here. Just let me show the document. Today class document. So this is today's topic. Yes, this is around 960 page document. 960 page document. This document for you only. I'll share with you. This is for you only. For you only. So today's class. Introduction to software. Software is a collection of programs such as C, C++, Java, and all these things. Software basically two categories. Yes, in the system software and application software. System software, it interacts with the hardware components. Example ways. Example ways. Application software for the purpose of application development. So this kind of applications. Example, application software examples. C, C++, Java, .NET and others. C, except operating systems. Yes, except ways. Yes, except operating systems. Remaining all are application softwares. Same points is there in document here. Just to follow this document. Nothing missing. Same points as is you can see. Okay, so what are things I'm explaining in the class here? Same you can see in the document. Just you follow document. Even order also, yes, same. No mismatch. Yes, your class order and document order is same. Line by every line will match. Even line also will not change here. Same, every line as the same like a class. Okay, just you follow this document here. Follow this document. Okay, right? So next, yes. So topic is about operating system. So what is OS? Topic is about OS. Yes, some question for yes. Some question. Very simple question. Very simple question. Can we run any program without OS? That is the question. Anyway, can you answer this? Can you answer this one? Can we run any program without OS? Maybe running C program, Java program, maybe some applications without OS. Can we run it? Yes, maybe Zoom application running without OS. Yes, Java program running without OS, C program running without. Is it possible? Can we run any program without OS?
No.
Yes, anyone can you answer this? No. Answer is no. No. Good. No, we can't. If no OS, no computer, first of all. Without OS, no computer. Yes, in computer, even mobile also OS required. Without OS, no device. This device is not working, right? So without OS, we can't do anything, right? Without OS, we can't do anything here. So OS required compulsory to run all software programs. To run all software programs, OS required. Okay, right? See, in your system, this is a BIOS. In your system, computer, this is a BIOS. See, except BIOS, except BIOS, is to run all programs. To run all programs, OS required. To run all programs, OS required. OS required. Okay. See, except BIOS to run all programs OS required. So BIOS is not a software. BIOS is not a software. So BIOS. What is BIOS? BIOS means BIOS stands for what? Anyone? BIOS stands for what? BIOS abbreviation. What is BIOS? BIOS abbreviation, at least abbreviation.
Basic input output system.
Good. Basic, basic, yes, input and output system. Basic input and output system. Okay. See, in computer, there is a BIOS setup. So as per BIOS setup only, system booting takes place. Booting depends on BIOS setup only, sir. So you can BIOS setup. Yes. So to boot your OS, BIOS setup required initially. So once BIOS setup is done, then installing your OS and booting your system. Okay, fine. So BIOS stands for basic input and output system. Yes, here BIOS is a hardware program. Yes, it's not a software, it's a hardware program. Yes, it's the electronic related program, device related program, hardware program. Okay. Yes, it is a chip level program. It's a chip level. It's a chip level program. It's a chip level program, right? Program, right? BIOS is a hard. Let me show the BIOS. BIOS in your system. BIOS image. See, this is BIOS. Yes, it's a BIOS. Here is a motherboard. In motherboard, this is a BIOS chip. So here's a BIOS chip, right? So once you power on our system, first of all, power goes to BIOS. Power goes to BIOS. Now this BIOS chip contains one program, BIOS program. That program is responsible to boot voice, booting voice. Okay, right? Miss, you're starting your voice. Booting is nothing but just starting your voice. Okay. So this BIOS is responsible. So once you power on your system, first of all, power goes to BIOS. So this BIOS contains one program, that hardware program. That program is responsible to boot your OS. So your BIOS is responsible. So your BIOS, yes, BIOS. BIOS is responsible to boot operating system, to boot operating system, to boot to boot operating system, right? So BIOS is responsible to boot operating system. So what is booting here? What is exactly booting? See, oh yes, here your OS is actually inside the disk. C drive, D drive, right? C drive. In C drive, Windows OS is there. So hard disk is for the storage. Hard disk is for the storage. Like OS storage and your file system and all that, right? Suppose in my system C drive, yes, all these software is installed here. So all these softwares are stored here. Next, Windows OS also in C drive, D drive. All my file system storage is a storage. Hard disk is a storage. Hard disk is storage. RAM is to run the programs. OS and programs all are running inside the RAM memory. RAM is to run all programs, including OS. Hard disk is a storage. Hard disk is storage. So once you power on your system here, so first of all, power goes to BIOS. Yes, that BIOS program, yes, will load. It will load OS from disk. Instead of C drive, this is a Windows OS, right? It's a Windows OS. Loading this OS from disk to RAM memory. Sorry. Yeah, loading. So loading ways from, yes, hard disk to RAM memory. It's a booting process. Yes, booting. Yes, here booting is a process. Yes, booting. Yes, booting is a process. Booting is a process of loading, loading ways, loading ways from hard disk to RAM memory, hard disk to RAM memory, RAM memory. It's a booting process. Yes, booting is a process. Booting is a process of loading ways from hard disk to RAM memory. So once loaded, your system is ready. Yes, see, it's a voice, right? It's a voice. Just a minute, let me have some water. Yes. So BIOS is a process of loading OS from hard disk to RAM memory. Okay. So BIOS just loading OS from hard disk to RAM memory. Once loaded, your system is ready. See, here is a Windows OS, right? So this is Windows OS. So here Windows OS. This is running inside the RAM memory. This OS is running inside the RAM memory. Now this OS is responsible to run every program. So here this OS. So initially loading OS into RAM memory. Half loading OS into RAM memory. Yes, this OS is responsible for all. Okay, let us see about OS. So this is about BIOS. Okay, fine. Now let us start OS. So what is operating system? So what is OS? So what is operating system? What is operating system? Yes, what is operating system? Let us see about OS. So what is OS? Yeah, these basics are required. Yeah, these are basics. Every software engineer must have these basics knowledge here. Okay. Yes, here there is a hardware. See, in your system, there is a hardware first of all. So computer. In computer, there is a hardware. First hardware layer. On top of hardware layer, operating system. So next, OS layer will come. On top of OS, all programs running like C and C++ program. Yes, maybe Java program. Maybe Java program running. Okay, maybe Python scripting running here. Maybe Python. All are running on top of OS. Python. Okay, suppose databases like Oracle database, MySQL. Yes, next even MS Office also OS required. Yes, MS Office. For everything OS required compulsory. Okay. Yes, all these are application softwares. These all are running on top of OS. So first hardware layer, on top of hardware OS running, on top of OS all programs running. So these are application softwares. All these are application softwares. All these are application softwares. So these are application softwares. All these application softwares running on top of OS. So you can OS interacting with the hardware components. So since OS interacting with hardware components is a system software. So OS is system software. It's a system software. So OS is system software. So this is your computer. So in computer, there is a hardware and these two layers is software. So this layer is a hardware layer. So these two layers is a software, hardware and software. See, computer ware, hardware and software, hardware and software, hardware and software. So here is a hardware and this is software, hardware and software. Right. Next here in software, there are two things: system software and application software. In software, system software, application software, system software, application software. See, software, system software, application software. This whole thing is a computer. That's it. This whole thing is a computer. Okay. So computer where? So there is a hardware parts and software parts. In software again, there are two things. So one is system software, another one is application software. Same thing explain notepad also. See that. So you get system software, it interacts with the hardware components. OS can interact with the hardware. OS interact with the hardware. So here this OS, yes, one second. So OS interacting with the hardware. So OS running on top of hardware, right? So OS can interact, right? So OS is system software. OS is a system software. Others are our application softwares. Okay, right? So here on top of OS, all are running application softwares like C, C++, Java, maybe Python, database, all are running on top of OS only. All are running on top of OS. So here OS just it's giving platform. So OS just it's giving platform. On top of OS, all are running. So acting like a platform. Here OS is acting like a platform. So what is OS means? Yes, it is a platform. OS it's a platform. Yes, it's a platform. It's a platform. It's a platform where we can run all application softwares. Where we can run all application softwares. All application software. Where we can run all the application software. Okay, it's a platform. So OS is a platform where we can run all application software. So OS acting like a platform. On top of it, all are running. Everything is running on top of OS only. See, presently in my system, Zoom app is running. That is running on top of OS. Right? Word document open, right? This Word document is running on top of OS. That MS Office, right? Okay, next. Browser open. Browser is also running on top of OS. Notepad is running on top of OS. Like there are different kind of things. Some are running C program, Java program. These are also running on top of OS. So all are running on top of OS. So OS is a platform, acting like a platform. On top of it, all are running. So, so what is OS means is a platform where we can run all application software. See, not only platform here, so but these programs generating some output. These programs generating some output, right? Yes, output of all these programs first of all transfer to OS. Output of these programs first of all transfer to OS and then deliver to output device. Okay, output of all these programs, application softwares. So first of all goes to OS, right? From the OS delivered to output device. Delivered to output device. Suppose input data, reading from the keyboard. Reading from the keyboard. So keyboard data first of all transfer to OS and then yes, sir, taken by these application software, right? So between application software and hardware, there is a voice. That voice acting like a mediator, just like a mediator, that middle layer between these two, right? So this is a mediator. So exactly you can say it's an interface, terminology interface. It's interface. So here voice acting like interface between application software and hardware components. Next point. Yes, it is an interface. Voice, yes, it is an interface. Yes, it's an interface. Yes, it's an interface between. Yes, OS is an interface between application software layer, application software, and hardware components. And hardware components. So these two layers, between these two layers, so OS acting like a yes, yes, OS acting like interface. So OS is an interface. It's an interface between this application software layer and hardware components. Just is interface, mediator between these two, right? Yes, next. One more point about OS. Inside of OS, there's a library. Inside of OS, there's a library. Inside the OS, there's a library. The library, yes, every OS contains its own library. Every OS contains its own library. Windows its own library, Linux its own library, Unix its own library, Mac its own library. In every OS, there's a library. That library contains what? Input or output functions. Yes, input and output functions to perform IO operations. To perform input and output operations. Input and output to is operations, IO operations, right? So every OS this library. Now, so this library actually responsible to communicate between application software and hardware components. Every OS has its own library. So which is responsible to communicate between application software and hardware components. So inside of OS, there are many things. Inside of OS, there are many things here. So libraries, one of things are libraries. So OS library to communicate between application software and hardware components, right? Every OS has its own library. Yes. Just remember this point here. In Java perspective, important this is that library, OS library. Okay, Java prospect important. Try to remember that here. Yes, every OS has its own library. Its own library. Yes, to communicate. Yes, to communicate between application software and hardware components. Communicate between application software and hardware components. So OS with the help of library only it will communicate between application software and hardware components. Next, one more point here. Suppose C program, C++, Java, all the programs running, right? Yes. Before going to run it here, so before going to run the programs here, first of all, all these programs, all these programs, okay, linking with OS library. Of linking with OS library, then execution starts. then output delivered to hardware components. Okay, see all these application software, okay, interacting with the hardware through the voice library. So don't have direct interaction. Application software never interact with the hardware through the voice library only here, right? Voice library. Okay. Yes. So these things before going to run all the programs, first of all, linking with voice library. Maybe C program, C++, Java, Python, all of this things linking with voice library. So first of all, linking. So all the programs, yes, every program has to link with voice library. Of linking, the next thing starts. That link may be statically linking or dynamically linking. Statically, dynamically. Statically or dynamically. Yes, statically, dynamically. These points we'll discuss in Java. In Java, I'll explain. Yes, Java features like independent platform. Java is an independent platform. So next session we are going to discuss about independent platform features. That time I'll clear it. Statically, dynamically linking. Statically linking, dynamically linking. That point I'll clear with Java features. Wait for some time. Wait for some time. Okay. So every program. Yes, remember this part. Yes, every program. Yes, every program. Yes, linking. Yes, every program has to link. Every program has to. Every program has to link with the voice library. Voice library. Voice library. Library. Yes, before going to run it. Before going to run. Before going to run. Yes, remember third and fourth points. Yes, in Java perspective, these are important. Okay, so every program has to link with voice library before going to run it. Suppose Java program dynamically linking, C program statically linking. That point next we'll discuss. Wait, with Java features I'll explain. So this is about voice. So this is about voice. Same thing explain document also. In document, see the document. Follow document. Voice. What is voice? Same that question. Can we run any program without voice? Answer is no. See, except BIOS to run all programs voice requires. BIOS stands for Basic Input and Output System. So BIOS is a hardware program. Yes, it's a chip level program, right? So BIOS is responsible to boot voice. To boot voice, right? So what is boot? Booting is a process of loading voice from hard disk to RAM memory. Okay, hard disk to RAM memory. That is booting. Yes, what is voice? It's a platform. Yes, what is an operating system? It's a platform where we can run all application softwares. It's an interface between hardware and application software. So every voice has its own libraries. Same point as this, even single word is not missing. Okay. So every program has to link with voice library before going to run it. Same point. See, hardware, on top of hardware, yes, there is a voice, on top of voice, all the programs running. Same points expenditure. Same as this is there in document. Just you follow document here. Running notes is not necessary. Just you follow document. Just you follow documents. Okay, fine. Yes, software, system software. In system software, about voice explained very clearly. Yes, application software for the purpose of application development. Applications like this. Yes, example C, C++, Java, and all these application software, right? Okay, fine. So in software, there is system software and application software. So what is Java? System software, application software. What do you understand? What is Java? System software, application software. Yes, as per this explanation, what you understand? System software, application software.
Application
Yes,
software.
yes. Java is a application software. Good. Java is a application software. Now let us see about applications. About application software. Now let us move to application software. See, application software. In application software, there are two things. There is a front-end software and back-end software. In application software, there is a front-end, back-end. Front-end, back-end. So what is front-end? What is back-end? Let us see. Front-end and back-end softwares. See, this is our application. Applications are like this. Web application. So this is web application architecture. Web application means web, World Wide Web means internet. Internet. So application which is running on the internet is a web application. Application running on the internet is a web application. Okay. Yes. See, in this application here, there are two parts. Here this is a front end and next back end. Okay, in application, there are two parts, front end and back end. Suppose let us take some application. Let us take Zoom application. So front end running on your browser. Yes, these actual application running are somewhere, some different system, means servers. Okay, so front end, back end. Suppose, for example, online purchasing. Online purchasing. In online purchasing, selecting items in your browser, right? So which item is login from your browser, but actual application running some different location. Okay, so application running at the servers for banking application. Suppose if you're doing some banking, filling some information that is running on your browser in your system, right? Actual application running at the banking servers, the bank servers, right? So this is it. So front end, back end. There are two things. Any application is a front end, back end. Front end, back end. So front end is a browser environment. So browser front end is a browser environment. Browser environment. For example, for example, yes, today you have registered, right? Registered your class. The registration form. So this is form, right? Yes, you have filled this form, right? Fill and register and join, right? So this form is a front end. That registration form, login form, it's a browser environment. So browser environment is a front end. So this is front end. Okay, so what are things we are able to see in the browser, that is front end? Maybe registration form, login form. Suppose your Gmail. Here we are able to see all these, right? It's a front end. So this is browser environment. So here we are able to see all these, right? So this is called as front end. So front end interactive with users, end users. Now here, so Zoom. So Zoom, we are the end user of Zoom application, right? We are using that application. We are filling our information, submitting it. So this is front end. So front end, right? Front end. So front end is a browser environment. So here front end is a browser environment, right? So this browser may be in your computer, right? Next back end, this running somewhere. Okay, right? So for example, registration form. For example, yes, that registration form data. For example, here registration form. Registration form, right? Fill this form, register and join. What happens here? Register and join. So here what happens? Let us see. That registration form, right? So that registration form data, simply the data posting to backend. So from the front end, your registration data simply posting to backend. At the backend, yes, some applications running and database running. There are different applications like maybe Java application running or .NET application running, Python. There are different applications running in the backend, right? Backend. Okay. So your data simply your browser data, the registration data simply posted to application taking the data, inserting the database, right? Yes. Yes. To develop this kind of applications, some software resources required. So what are resources here? So front-end development is a UA developer. That role is UA developer. Front-end development is a UA developer. Is a UA developer role. Next in backend, there is the application developer and database developer. In backend, database developer requires and application developer requires. Okay, right? So application developer requires. Fine. So UA developer, next database developer, and apart from it, application backend application developer. Suppose Java, .NET. So these applications changing, but front end and the database same. For all developers, front end and database same. Only this is change. This layer changes. Suppose Java. Suppose here Java application developer. Suppose if it is Java application developer. So there are three roles: EA developer role, Java application developer role, yes, next database developer role. So front end developer role, in back end application developer and database. Totally three roles. Three roles, right? Previously, three roles, three resources. Three roles and three resources. But nowadays, companies are expecting for all three roles. Companies are expecting multiple skills from you. Multiple skills. So who are performing all three roles is a full stack. Who are yes performing all three roles like a UA developer, like a database developer, like a yes application developer. That is full stack. Yes, who are performing all the roles is a full stack. Okay, suppose if it's Java full stack, here Java comes. Here Java comes, then Java full stack. Suppose here .NET comes, .NET full stack. Python comes, Python full stack. Okay, so it depends on this thing here. That stack full stack changes. Java full stack, .NET full stack, Python full stack, Node.js full stack. So main stack, mean stack, like this, there are different kind of things. That depends on application using here. Okay, right? Now, as a Java developer, yes. So your application running Java is running here, right? Now, what is Java here? Front end or back end? So Java is a backend application software. Java comes under backend. Java is a backend. Java is a backend. Okay, right? See here, application software, front end software, backend software. So Java is a backend. Java comes on backend software. Java is a backend server-side programming to develop server-side applications. Yes, it's a backend. So Java is a backend software. I think clear. So Java is a backend application software. In application software, front end, backend. Java is a Java is a backend application software, right? See, HTML, CSS, JavaScript, these are the front end softwares. They are front end. Okay, fine. Now here, yes, front end, back end. Yes, both cases, language and package available. Language and packages. So package, ready-made one, ERP and all that packages. Okay, right? Languages. In language, we should write the code. So what is Java? Language or package? Java is a language, right? Java is a backend programming language, simply. Yes, Java is a backend programming language. Which language? Is a program backend programming language, right? Okay, so Java, what is Java? Java is a application software. Java is application software. Yes, in application software is a backend software. Backend. Yes, in this backend, yes, this language, backend language. That's it here. So Java is a language. Java is language. Now let us see about languages. Software language. Languages. Languages. See, in software, languages are basically two categories. Basically two categories. So first one is computer. Computer understandable language. Computer is understandable. Computer understandable language. Computer understandable languages. First one computer understandable language. Next one, yes, user understandable means our language. User understandable. So languages, computer understandable language. Next, user understandable language. So we are understanding some language, computer understanding different language. Right? Let us see about these things here. So first of all, about computer understandable language. So computer understandable language. So generally, anyone says that computer understandable language means it's a machine language binary code, right? Now, present generation of computers, yes, working with binary code, present generation. Okay, actually, that computer understandable language, yes, it depends. It depends. It depends on generation of computers. Generation of computers. Depends on generation of computers. Depends on generation of computers. Yes. Again, one more question for you guys. How many generation of computers? Yes, anyone? How many generation of computers? How many generation of computers? Yes, anyone? Can you answer this? How many generation of computers? Search in Google. Yes, search in Google, you can get the information. So there are 5 generations. 5 generations. 5 generations, right? 5 generations. So first one, first generation computer. So initially computer. First generation computer. Yes, first generation computer is a vacuum tubes. Vacuum tubes based computer. Okay, so vacuum tubes based computer, first generation. Second generation, transistor. Yes, it's the electronic subject. Transistors based. transistors, transistors based, transistor based. Next, third generation is IC based. IC means integrated circuits, IC based computers. Fourth generation, processor based, processor based. Yeah, this is present generation. So this is present generation. Processor. Now we are using processor based computer. Next, feature generation, fifth gen. So what is fifth gen computer? Feature generation. Tell me. Feature generation. Presently we are using processor based computers. In future, yes, almost all devices are processor based devices presently we are using. Future, what kind of devices we are going to use? So future, yes, future is AI based, all AI based computers. Yes, AI based machines we are going to use in the future. Right? Yes, yeah, I'll explain about AI also. Just 5 to 10 minutes I'll explain about AI also. What is exactly AI? I'll explain. So presently processor based computer. See, processor based computer understandable language. Understandable language. Understandable language is binary code. Yes, it's a binary code. So binary code is like a zeros ones format, like zeros ones format. It's called as binary code. Okay, processor based computer understandable language binary code. Next feature AI based. Yes. So AI based computer understandable language. So what is AI based computer understandable language? See, AI based computer understandable language is English. Yes, it can understand our English. Okay, AI based computer can understand our English. English. So AI based, it's English. It can understand our English. So what is exactly AI? Yes, artificial intelligence. What is artificial intelligence? Let me explain. So what is exactly artificial intelligence? See, AI is a technology. It is a technology to make machines work. Machines working like a machines working like a human. Working like a human. Human, right? Human. Okay, so AI is a technology to make machines work like a human, right? So wherever human, yes, activity said that AI-based machine work. So without any human intervention work here. Okay, so AI machines, AI machines, yes, will work. So without any human intervention, without any human intervention. I'll tell you some examples. A examples here. For example, in our home, suppose there's a AI-based machine is there. That AI-based machine just yes, once you switch on that AI-based machine, okay, that simply it works like your family member. That AI-based machine works like a family member. Suppose if you're saying some stories, yes, it will listen for our stories. It will remember. So that AI-based machine input data, voice data and text data. Okay, voice data as well as text data also. So like a human being, see, we are taking voice data and text data, right? See, today I'm explaining class. In class explanation, yes, voice data. See, voice, I'm explaining, right? So you able to listen my voice, right? You able to listen my voice and taking as input and remembering, right? Even text, yes, I'm typing some text. Yes, you able to read text, right? So reading text. So your input, yes, for you input data. What are input I'm giving here? Voice data I'm giving and text data. Both are giving, right? So for you inputs, I'm giving voice data and text data. Same AI based machine, exactly like human being. So that AI machine Okay, AI machine in your home, it will listen for your voice, and if you giving text data, it will take text data also. Okay, so taking voice and text data, remember, it will remember, right? It will remember. Suppose if you ask in future, if you're asking any question, yes, for this question, relevant answer, searching in the data and picking and giving, right? Okay, that relevant question relevant answer, we will search it. So behind of a machine, there are some language working. Maybe a tool, behind of a tool, some language. That language may be Java language, Python scripting, and R language. So behind of every a machine or a tool, some programs, for example, Chat GPT tool, behind of Chat GPT, Python scripting is working. Okay, yes, some tools may be Java using, some tools may be using R language. So you get different like behind of every A machine, every A tool, some language is working to process data to pick answer for your question. To pick answer for your question, some programs running, right? So we will process the data, giving output simply, right? Okay. So here that AI-based machine simply working like a human being here. Okay, yes, if say some instructions, it will listen for your instruction. Suppose in your home, a mission is there. If say something that mission, yes, will listen for your instructions. Maybe closing door and opening door, power off, power on, fan off, on like this. Okay, suppose washing machine on off. So that AI-based machine will take care of everything, working like a human being. So it works like your assistant, like your family member, right? So whatever you says, it will listen for all. Okay. Suppose sometimes maybe you feeling lonely. No one is there in your home. You feeling lonely. Not necessarily you can talk to AI machine. Okay, just entertain with AI machine. Just talk to AI machine. That AI machine will respond to your questions. Okay. AI based machine will respond to your questions, right? That is AI based machine, right? Yes. And one more thing here. AI based machine. In AI also latest AI, not only taking your voice data, yes, voice data, text data, taking and storing into that machine, right? So whenever you asking question, then take that data and giving, right? Not on that here. Based on that existing data, it will predict a feature also. So based on that existing data, it will predict a feature also. Means so feature data also generating. Yes, it will generate feature also. Feature data, feature coming. So what next? That we are that is called generative AI. Okay. See, not only existing data, that old AI is just taking existing data and giving output simply, giving answer, reply, right? Yes, apart from this, new AI, yes, it will future also, it will predict the future also. Okay, generates new data. Based on old data, it will generate new data. That is generative AI. So generative AI means based on old data, it will generate new data. Itself, it will generate new data. You need not to give anything here. So future predictions based on that history and all that here, it will generate new data. That is generative AI. Generative AI. Okay, fine. Yes, that is about AI machine here. Suppose, for example, AI based car. AI based car. Yes. Best example Tesla. Tesla is a AI based car, right? Tesla. Elon Musk. Yes, lot of popularity for the Tesla, right? Elon Musk is the owner for Tesla, right? Tesla. Yes, it's a AI-based car. Driverless car. It's a driverless car. No driver for this. Driverless car. Driverless car, right? Driverless car. That is a Tesla car integrating with your mobile. Integrating with your mobile. So through the mobile, you can give the instructions. Okay. Through the mobile, you can give the instructions as per your instruction that Tesla car is working. Okay, Tesla car working, right? Okay, so it has a parking place. Yes, taking from the parking, taking out of parking, right? Yes, it says instruction mobile, automatically that car will come out of the parking. If you want to put into parking, it will go to parking place automatically, right? Suppose if you want to pick somebody, yes, once you says direction as per your direction, yes, that route as per your route, it goes to location and pick and drop. So picking some persons, maybe picking some items, so pick and drop. Without drive, it will reach, right? So the AI based that car is yes without driver. So acting like a driver is working like a driver, pick up and drop. So acting like a driver, right? Not only that here, yes. So there are many AI based tools. Suppose healthcare system. In healthcare system also, yes, AI based tools are there. Okay. So that healthcare system. So once you yes that the tools. So once yes the tools will simply attach to your body. So once so for example wristwatch best example. AI based wristwatch. Okay. Yes, that will monitor your health. So monitoring your heartbeat, okay, blood pressure. Okay, next. Yes, all these many things like walking, how many foot, yes, how many steps you walked, and everything will monitor. And even you it will guide you like a doctor. This hour, yes, maybe 200 foots are required. Next hour, every hour it will give the instruction because I'm using that wristwatch already. Okay, that AI based wristwatch I'm using here, minute to minute it will monitor. So whatever I'm doing some act, suppose I'm walking, yes, walking detected, immediately says that what walking detected. Suppose if I'm doing some gym items, yes, some device detected, some active detected, automatically that shows all the messages. Connects, you need something, yes, heartbeat system, even ECG also. ECG also it will give it. Yes, as per your heart, ECG like that on all this right that health monitoring. Like that, there are many AI-based tools are there. Next, even manufacturing industry, there also we can use AI machines like a human working, right? Like constructions. So everywhere. So AI-based machines working like a driver, working like engineer, working like a doctor. So like in place of human being, AI comes. AI. That is AI world actually. So wherever human activity is there, every activity AI will do. AI will do right. That is exactly AI. Okay, right? Yes. Okay, fine. Here, one more thing here. To utilize that AI machines, yes, it should be more intelligent than the AI machines. Otherwise, you can't utilize. Okay, you have to operate that AI machines, right? To operate that AI machines, you should be more intelligent. In our life, daily life, you have to use the AI machines. You should be, yes, intelligent enough, yes, to operate AI machines. Okay, right? Yes, one more thing here. One, I'll tell you one analysis here in AI. See, everyone says, so once AI world comes, loss of jobs. Loss of jobs, right? So when AI world comes, yes, after 2035, completely AI-based world. Means 10 years. Still we have the 10 years, no worry. Yes, 2035. By the year 2035, completely AI-based world. Okay. So once AI-based will come here, yes, in place of human being, all AI tools working. Even yes, software job also AI-based machines will work, will do it. Developing codes, developing code, right? Code development. Next, infrastructure management, configurations, and everything AI-based tool will do. Will do. So whatever we are doing here, same thing AI-based tool will work, right? But AI-based tool itself, it won't work. So to initiate AI-based tool, we have to work first of all. So we have to use that AI-based tool. That's it here. Okay. So one second. Here's by 2035 AI-based tool, AI-based world, right? So once AI-based world comes, maybe loss of jobs. Many are saying that loss of jobs. No chance. I'll tell you some analysis. See, 1990, 90s periods. How much world population? I think maybe 200 crores. Total world population, right? Yes, 2000 year. Yes, in 2000 year. Yes, maybe 400 population. Right? Yes, next 2010, that world population is yes around yes 600 crores. Okay, now 2020. Now presently, yes, 800 crores, right? Okay, 2030. Yes, that may be 1000 crores population. Yes, 2035. Yes, that world population will be 1200 crores, right? See, here that population increasing on the earth, right? Population increasing. Yes, See, 1990s here, 200 crores of population. Okay, it's almost here some little bit technology mobile is like landline phones, some TVs, some little bit technology, very less technology is that time, right? That technology is able to serve 200 crores of people. Suppose same technology, if it is using 2000 year, the technology not enough to serve this much of people, right? So for that purpose, technology improved. Yes, even technology improved here 2000 year. Yes, unable to meet the requirements of 400 crores of people. Next, 2010. Yes, by 2010, lot of technology increased, like mobile phones. Yes, even yes, Facebook, the social media revolution started. Social media, mobile phones, and everything is right. Even everything is there here. Even still, yes, unable to meet the requirements of 600 people, right? Okay, right? Yes, here that mobile phones and social media and all these, right? Yes, now 2020. Yes, to meet the requirements of 800 crores of people here. Yes, we are using lot of technology. Social media we are using. Yes, mobile phones using, smartphones using, many things using, right? Even many things using here, still yes, lagging in finishing works, right? Because the population is more. Okay, so with the help of all the technologies, we are able to meet the requirements of 800 crores of people. Okay, human efforts plus the technology efforts. So combinedly handling 800 crores of people requirements, right? See, by 2035, 1,200 crores of people, right? To meet the requirements of 1,200 crores of population, yes, yes, present technology is not enough. Okay, present human efforts not enough. Present technology is not enough. Some advanced technology required. That advanced technology is AI. Yes, even AI comes, no loss of jobs. AI plus human efforts. Human efforts. Yes, human efforts. Yes, human efforts. Yes, meets requirements of 1,200 crores of population. Okay, even AI is there, human efforts required. Human efforts required. Without human efforts, AI will not run. Even utilizing that AI, even utilizing the AI, your efforts required. Otherwise, cannot, right? So here, don't think loss of jobs. No loss of jobs. World is same world. Only technology changes. Upgrading technology. So here, population increasing to meet the requirements of 1,200 crores of people. Yes, we need this current technology may not be enough. Okay, currently just we are using social media, and next we are using mobile phones and smartphones. Okay, so this technology is not enough. So we need compulsory some advanced technology. That advanced is AI. So AI plus human efforts meeting 200 crores of people requirements. That's it. So you guys don't worry. Yes, more even experts also says that loss of jobs once AI comes. That is wrong. 100% wrong. Okay, even experts also talk same thing. That is 100% wrong here. Folks, compulsory human efforts required. Yes, at the same time, AI also required. Otherwise, you can't. Okay, right? Even rocket science also changes in future. Okay. Yes, see, for example, here Hyderabad to US. Okay, weekly, every week going from Hyderabad to US, right? In future, yes, from Earth to Moon, maybe traveling in future. That may happens. Okay, Earth to Moon. Yes, next different locations, not only from the Earth here. Maybe working from the universe. In universe, different planets, right? Maybe chance of moving to different planets. That we need lot of technology. Okay, that is future, right? So you guys don't worry. Yes, even AI comes, jobs will be there. Okay, no worry about it. So that's all about AI based world here. So next here, yes, computer understandable language. Yes, it's a binary code that is called as low level language, right? Yes, computer understandable language, low level language, user understandable, that is called as high level language. So language is basically two categories. First one, yes, low level language. Low level language, low level languages, and second one, high level language. Low level and high level. Low level and high level language. Yes, low level language. Low level language. Yes, it's a computer understandable language. Yes, it is a system understandable language. System means computer is system understandable. System understandable language. It's a system understandable language. Yes, system means processor. System means that microprocessor. It's a microprocessor. Okay, system is processors. It's a processor. Processor like 8085, that is old one. 8086 is new one. So before 90s period, 8085 processor. Now presently from since 90s we are using 8086. Right? Yes, it's a processor understandable language. It is a processor. It's a processor understandable language. Processor understandable. Processor understandable language. It's a processor understandable language. Yes, it is in the form of binary codes. Yes, it is in the form of binary codes. The form of binary codes. So binary code is something like zeros ones. Yes, it is called as machine language. Yes, it is called as machine language. 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 So it's a low level language, right? Next, so present generation of computers using this one here. We are at this location here only. AI. So presently we don't have very strong AI. Weak AI is there, like Alexa. Alexa is weak. It's not a strong AI. Right? Tesla car is a strong AI. Tesla is a strong. Okay, fine. 1 second, just a minute. Hello. Yeah, भैया बोलो. Yeah, बोलो भैया. लोकेशन भी जाना है. हाँ, लोकेशन भी जाता हूँ अभी. Sure, sure. Okay. Yeah, high level language. High level language. Yes, what is high level language? Yes, yes, it's a user understandable language. It's a user understandable. User understandable. Yes, it's a user understandable language. It's a user understandable language. Yes, it is English. Simply, it's an English. It's an English. It's an English, right? It's an English. Every program is in a high level language only. Okay, high level language. Example, Java is a high level language. A Java program looks like English language. Okay, right? A C and C++ looks like English language. Python scripting is like a English language. Some HTML is like English language. All they are high level language. So high level language, yes, it's an English. Yes, is a user understandable language. These all the programs in a high level language only. We can understand it very easily. Right? Easy to understand it. High level language, it's a user understandable, is an English here. Yes, easy to understand it. Easy to understand it. Easy to understand it. Easy to understand. Okay. So Java program, C++. See some one more question for you guys. So which is generated? Which is first generated high level language? Anyone idea? Which is first generated high level language? Which is first generated high level language? No idea? C language. Yes, before C language, we have the machine language and assembly languages. Machine and assembly language. C language is a first, yes, C language is a first generated high level language. Next. Yes. So who has developed here? Developed by Dennis Rich. Dennis Rich, right? Dennis Rich at AT&T Bell Labs, yes, AT&T pillars. Yes, yeah. Yes. So first C language. Yes. And next OOPS concept, then C++. After C++, Python. After Python, yes, Java, Visual Basic, Java, like that. 1 second. The software history. One day I will explain about complete software history. Since 1945 to today, what was happened? I'll explain very clearly. Software history. Yeah, this is one day I will take it. Yes. Before going to OOPS, this topic is there. So 1945 initially machine language and assembly languages. Later MS-DOS, C language, Unix, C++, Python, Windows, year-wise. Since 1993, I have the software awareness. My engineering started in 93, 97 completed. So since 1993, yes, I'm thinking about computers. I have the software awareness since 1993. So almost all I know. I know almost all what was happening in software field. I know everything here. So which year wise? So Java, SAP, mainframes, AS1, Windows NT, .NET, next Linux OS, next warehousing tools, ERP, Oracle ERP, testing tools, Salesforce. Okay, like that. So here, yes, Java Spring Framework, next Hadoop, Scala, Selenium, Android, Cloud, AWS, ServiceNow, DevOps, yes, like Spring Frameworks, next R language, AI, right, like this. So different kind of year wise. This history later I explain. Yes, we'll see later. Okay, we'll see later. Okay, fine. Now here, so Java, C, C++, and all of these things are high-level language, right? This high-level language has to convert into binary codes. High-level language to binary codes. Binary codes. Otherwise, system cannot understand it. Yes, system cannot understand our Java programs, C programs. So these are in English. Java, C, C++, all the programs in English. So computer cannot understand it. Someone has to convert from high level language to binary codes. So which one will convert? Anyone idea? So which one will convert from high level language to binary codes? Either interpreter, yes, either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler, yes, will convert. Will convert from high level language to binary codes. Interpreters and compilers will convert from high level language to binary codes. After converting, then generating output simply. So interpreter and compilers. So next topic is about interpreter and compiler. So about interpreter and compiler, tomorrow topic. Tomorrow we'll discuss. Yes, 1 second. Today topic. Let me review today document. Same, all these topics are in document here. See low level, high level language. See generation of computers also prepared here. Okay, right? See about low level language, explain clearly. About high level language, same, it's there in document here. Just you follow document here. So which is first developed high level language? C language. So every point is there in document. Okay, just you follow document here. See explanation purpose. Sometimes I'm using notepad, sometimes I'm using word. Suppose any drawing comes, I'm using word, right? So yes, with the help of this word and this notepad, I'm explaining your class, right? Same thing as this prepared in the document. This document for you only. Even single line also not missing. Same as this, you can same order of explanation document are the same. So this document is completely my experience. See, most of the trainers they will copy from the different websites. Yes, they'll prepare some PDFs, right? Same thing share with you. But my document is not like that here. Completely purely my experience this is. See that even terminology, even order of explanation analysis, nowhere matching with any websites. Okay, so this complete different. Yes, so this is today topic. Up to this completed here. Tomorrow topic high level to binary code. Yes, interpreter or compiler convert from high level language to binary code. Here difference between interpreter and compiler. Tomorrow we'll discuss. Right? interpreter and compiler. After explaining about interpreter, then starting Java. Tomorrow I'll be introducing Java. So Java depends on what? Is it compiler based or interpreter based? The topic tomorrow we'll discuss. Tomorrow I'm going to introduce Java. Tomorrow starting Java. Yeah, that's all guys. Any doubts for today? Just wait, don't leave. Any doubts? Any doubts? Yes, any doubts, guys?
No, sir.